Hey everyone, welcome back to the Breakpoint Show. As you can see, it's a little different today on July 24th. So we're recording this on July 24th. And it's later in the day for us in the United States. So Martin is technically still on vacation, so he's enjoying his family. And so we thought we'd bring in another American, Harry Pierson, to join us. So Harry is going to talk about DBOS.
DBOS.
So he can define it. He can tell you what it is. He can tell you about the company. I think it's really cool. It's a research topic that came out of MIT. So anything MIT, I think, is pretty cool. But then we have Khalid. So I've got my hands the wrong way. So there's Khalid. So welcome, Khalid. How are you doing?
Yeah, I'm doing pretty good. A little bit more breathing room since Martin's not here. You know, you can kind of stretch out a little bit.
Yeah, those the Belgians, they just take up a lot of space. They're like, I won't say egos, but the machine, I will say Martin the machine takes up a lot of space. So
is Martin going to come back the way you guys are talking about him? Maybe he's going to stay.
We always tease him.
Yeah.
His nickname is the Machine because when he works at JetBrains also, and I worked with him for a number of years, and I thought there was like 3 of them because he just kicked out like code and writing, and I mean, but this is before he had a kid. So I always told him once he had a kid that all that time goes away. So
now he's going down to 2, Martins.
Yeah. Now he's probably down to 2. Yeah, he's still prolific. So, but hey, Harry, so give us a little insight into who you are and who you work for, maybe some background, because your background's also interesting.
Yeah, well, so I mean, I met Woody years ago. I can't even remember exactly when I worked at Microsoft. So I was at Microsoft for about 20 years. I worked on a variety of interesting projects. I started in the field and eventually, in fact, speaking of kids, I was in a job where I was traveling about 50% of the time. And then I had my first kid. And so that didn't really work very well. So I moved to a corporate job. I worked for the team was called .NEAT, the .NET Enterprise Architecture team, which was a cool project, but a dumb name. So we changed it to Architecture Strategy. This was part of DPE. I think that's probably when I met you, Chris.
Mm-hmm. Yep.
And then I moved over to the product groups. I worked on Iron Python. I worked on Windows. I was part of the team that did Windows Runtime for Windows 8. I switched over from program management to dev. I worked on Midori, which was a research project operating system built in C#. And then I went back to Windows as a developer for a while. I spent a few years building blockchain developer tools outside of Microsoft. And then last year I joined DBOS, which is a relatively new startup. The company's been around about a year and a quarter now. So it started last March. It started as a research project between MIT and Stanford. So as you say, you like MIT, at some point you might need to meet our CTO, the legendary Mike Stonebreaker. Mike invented Postgres. You might have heard of it. In fact, one of the things that's exciting about working with him is that he built a query language that's not SQL. In fact, it was called Quell. I don't know if you know this, but the reason SQL was called SQL was it was the sequel to Quell. That
really?
Reverse engineered the SQL acronym out of it later.
Interesting.
Well, I haven't had a chance to really work with Quell. Apparently, Ingress still supports it. In Ingress, I don't remember the name of the company that has support contracts for Ingress. There is still some of it out there. But it's a much more composable language apparently than SQL. So I haven't had a chance to study it, but I with a company as with a vision as revolutionary as what DBOS is trying to accomplish, it's like I hope to get an opportunity to play with some additional query language stuff because
cool.
I work on developer the developer experience for DBOS. So the research project between, I've gotten a little off track, sorry. The research project between MIT and Stanford was about actually building an operating system on top of a relational model. So the easiest way to explain this is, you've probably heard the term in Linux, everything is a file. Mm-hmm. And that's not really a good model of what the operating system needs to manage, right? An unstructured stream of bytes, that's not exactly a good model for anything. We actually believe the operating system, everything is a table. And that's a much better model of what the operating system has to manage internally. And if you know anything about how databases are built, they basically don't trust the operating system for anything. I have been, of course, a heavy user of databases for my entire career, but working on the internals of databases is a relatively new thing for me. And so I've been working through the CMU class, Intro to Databases by Andy Pavlo. And one of the talks he gives is about, don't use memory map. You want to, you don't trust the operating system to know the right time to flush things to disk and that kind of stuff. So the long-term vision for DBOS is DBOS, Database Operating System. But that's the long-term vision, right? In order to be able to accomplish things that revolutionary, you need to be able to start with smaller tasks. And so what we have today is a TypeScript framework called DBOS Transact and a cloud hosting service for Transact applications called DBOS Cloud. And Transact is primarily a framework for building reliable, observable backends. So, we don't work at anything with the UI stuff. We just hired a front-end developer because none of us, I'm the best front-end developer we had until we hired Leander, which is bad. I'm no good. And so the idea there is to be able to radically simplify what it takes to build the back end of your application. And then to be able to radically simplify the way to build the back end of the application and radically simplify the deployment, like one-click deployment to the cloud, upgrades, and what have you. And we also provide a variety of other really interesting technologies. We have a time travel debugger for your database. I worked with some folks at Microsoft who did the time travel debugger there. I actually built the time travel debugger as part of the blockchain company that I worked for in between Microsoft and DBOS. And this is a radically different kind of approach for doing time travel. This is time traveling the data in your database. And I got to build it, but most of the design came from Chin Lee, one of the PhD grads that we have. She was part of the research project at Stanford and one of the founders of DBOS. And so the research that she's done around how to do this kind of time travel debugging for a database is revolutionary. And
oh, cool.
Really
we have tons of questions around that.
Yep. Good. I built it, so I can answer them.
Awesome. So, well, let's get started. So, yeah. Khalid, I'll let Khalid start because I'm a gentleman, and I'll let you go first.
Well, it's interesting. Like I was watching a lot of the DBOS content. If you folks want to get that content, go just search on YouTube, and you'll see a lot of
we'll
live
put
streams.
in the show notes. We'll put the YouTube video in the show notes.
DBOS.dev.
Yeah, DBOS.dev. But I was looking at the time travel demo, and it was very cool. And it started like the dev in me wanted to know, how does that happen? Because you had mentioned Mike Stonebreaker, which sounds like a Norse god, by the way.
Well, my wife's a geologist. As soon as she heard I was up for this job, she's like, "You're taking that job."
But he is the co-founder of Postgres and creator.
Yep.
So obviously picking Postgres as the database that kind of underpins all of DBOS. Is there some kind of feature in Postgres that DBOS is utilizing in terms of like temporal data storage that allows for this kind of time travel debugging to kind of happen?
Not really. The way that multi-version concurrency control is implemented inside of Postgres in many ways, we're replicating that for our Providence database. So let's back up for one quick second. The primary point of DBOS Transact is to be able to deliver a easy to radically simplified backend infrastructure programming platform. We deliver a platform where you write a series of workflow steps, right? So this is a fairly common way of building applications where you have a series of transactional steps that are, wired together in a workflow. So you have a graph, maybe you have multiple steps going on at the same time, what have you. Each of those individual steps is transactional, either in terms of it's talking to your database, you're changing data in your database, or it's communicating to some external service. And you want to make sure that so writing the simple, like thinking through the business logic of your application, it's usually pretty simple, right? We use this canonical example of the buy button of an e-commerce website. You want to reserve inventory, you want to talk to PayPal or Stripe, and then you want to fulfill the order, assuming the payment goes through. And that's pretty straightforward, as long as nothing goes wrong. And of course, it's as soon as something goes wrong that the problems start. And so you have to start off with, do I have inventory? Does the payment go through? Is the shipping address that the product was supposed to be shipped to correct? So these are the kinds of sort of normal business flow errors that you have to be able to write for. And what do you do if you go to deliver the product and there's no house at the address is wrong? There's also a variety of errors that can go wrong that have to do completely with infrastructure. Like, what do you do if while you're waiting to hear back from Stripe or PayPal, the hardware crashes, the operating system crashes, CrowdStrike pushes a new update, whatever. You need to be able to have an infrastructure that automatically can recover from that. And what we've found is that a vast majority of these kinds of applications, you're writing what Mike likes to call the oops code, right? So like 10 to 20% of your code is the actual business logic, and the other 80 or 90% is the oops code. There's a bank that he was working with where 40% of their code base was just making sure that workflows were executing once and only once, right? And that was, and of course, there's more to it than just that one piece of it. So the way that you do that is you record your steps, right? When you write stuff to the database, you call a function. Well, that function is going to return something. It might return void, but you write that to the database. And so you're keeping a history of all of the things that you do. So by using the transactional nature of the database and storing all of your system state in the database, you can make the system reliable. And there's more to it than that, but we implement that for you. So we talk about this idea of a 10x gain in developer productivity because you don't have to write all that oops code. Well, all of that data also can be used for doing time travel debugging. We also, on top of that, we use the same kind of replication log infrastructure to write out provenance information. So for every change to the database, we write a record into a write store, right? I mean, so it's I'm blanking on the term for it. It's obviously you're only reading from it, so you only write to it. So you never make changes to it. So it's an append only. That's the term I was looking for. So, and when we do that append only, getting back to your question, Khalid, we put the information about the transactional state that was happening at the time that the transaction was executed. So this is the multi-version concurrency control infrastructure that Postgres uses. And so whenever you start a transaction in Postgres, you record information about these are the maximum and minimum transactions that were active at the time. Here's another list of transactions. There's all this information is used to be able to determine these records are visible to this transaction and these records are not. And so by using the infrastructure for that, it's typically used for like hot standby, right? I'm going to replicate all of my write-ahead log to another server, so that way if server A goes down, I can switch over to server B. Oh, Luna's getting a little, sorry, my dog is paying close attention to this discussion, and she's back asleep. But if you use that same replication infrastructure, you can also get the information about the transactional state of the system as it was happening at the time. And so we write all that information out to a separate database, the Providence database, a data warehouse, if you will. And you can keep that information as long as you want, right? Storage is pretty cheap these days. So It's a pretty revolutionary technology. It's not unique in the industry. Oracle has something similar. The difference with Oracle is, as I understand it, and I'm not an expert in Oracle, as you can imagine, I didn't spend a lot of time working on Oracle when I was at Microsoft, and I don't spend a lot of time in Oracle working at DBOS. But they have a time travel that's measured in, like, I think it defaults to 15 minutes, and you can change it to like an hour. Our free plan comes with 3 days of storage for Providence database, and the $40 professional plan ups that to 30 days. And you can basically keep it for an arbitrary amount of time if you want to. It's just database records. So there's a lot of the time travel debugging depends on that infrastructure, having the information about what were the transactions that were active at the time that this workflow executed. And so there's similar infrastructure in other databases. I don't know the internals of other databases. I don't really know the internals really of DBOS, but I as you can imagine, I do understand how the MVCC infrastructure works, because I had to write all the translations for all the transformations. So when you execute a query, we transform it on the fly. And what's really cool about that, to go back to the demo that you were mentioning, Khalid, is you can do this kind of stuff instantly. We've actually added some custom commands. You can say like DBOS timestamp or DBOS workflow ID and instantly time travel to some other point in time. Now, normally in other platforms, this requires, okay, we're going to restore the database as it existed at this time. We're doing checkpoints on every workflow. Great, that's great, but that takes time and a place to restore it to and stuff like that. So the ability to be able to just sort of jump around in time without having to do all that kind of restoration is huge for the developer productivity.
Yeah, I mean, I was going to say specifically, right? Like Chris and I probably worked in Azure, right? You've used logging systems, you've used all these kind of things, and you inevitably run into an exception or an error where you've maybe thought you had enough logs, you had enough tracing, you had enough whatever in place, but then you quickly realize, oh, there's a blind spot here that we didn't realize, and we have no clue how to figure this out.
Or all your code is running in parallel, and that is a whole nother can of worms to try to sort through. Is that all that parallel code? How do you keep track of the state of all those different threads potentially in your executable?
Yeah, one of the things that's really fascinating is the original research paper, which was published last year at VLDB, that my colleague Chin wrote. The paper is called R Cubed: Record, Replay, and Retroact. And what's cool about the retroact is most time travel debugging systems work the same way. They're tracers, right? Execute, capture state. Execute an instruction, capture state. Well, that's great until you need to change the code. Then your trace is useless. Here, we're actually, because we're time traveling the data and not time traveling the code, you can actually modify your code. And so, like, that's something I've never seen before, right? The ability to say, okay, I'm going to change my code because I've got some kind of problem with the state in the database. So I change the code to where I can query what that state is, either doing it through code or through interactive tools. The demo, I think, that you were mentioning, Khalid, we're using pSQL. We are in the process of improving the SQL parsing of the proxy, the debug proxy. So that way we want to be able to make basically general purpose Postgres tools like pgadmin and dbeaver and stuff like that work with our backend. That does not work yet. I'm doing a podcast instead of writing the world's ugliest case statement right now. Did you know there are 250 different like AST nodes in the SQL language as Postgres implements it? I do now.
Well, I want to actually ask you, you talked a lot about transactions and kind of the transaction log in Postgres. Just reading through the DBOS documentation, there seems to be like 3 pillars to DBOS, right? Workflows, transactions, and communicators.
Yep.
For folks out there who are maybe interested in checking out DBOS, maybe just give like a high level overview of like why those 3 pillars are there and what they could potentially be used.
I can even tell you about a 4th one that was recently added, which is also work that I did.
Breaking
Ooh,
news.
we have breaking news.
To be very clear, I've got some really great teammates, and for example, we're working on a Python version, and even though I was the Iron Python program manager, I'm not actually involved very much with that project. So these are some of the most brilliant people I've ever had a chance to work with. But we are in fact picking a point in time and a couple of technologies that are very specific to stuff that I worked on. So I don't want to make it sound like, yes, I'm the big developer. No, these guys are. I had a chat with one of my teammates, Max, who actually just got married over the weekend. He's like, I don't understand what you do. And it's like, that's okay. I don't understand what you do either. He's one of our cloud guys. All of the way that we do the DBOS Cloud hosting and what have you, like that stuff's like completely opaque to me. I don't understand it very well. He's a operating system researcher that came on to DBOS. So like he's forgotten more about how operating systems work than I know. And I used to work in Windows. So, but again, I worked in Windows developer stuff, not like the core operating system as much. So anyway, the point of this is that we have, when you're going to build any kind of workflow, you think of it as a series of steps, right? Mm-hmm. And that's really easy to model in code, right? Call this function, call this function, call this function. Those functions fall into two categories in DBOS: external and internal. So external are called communicators. And so if you're going to communicate with some kind of external system, like we were talking about the e-commerce scenario earlier, you're going to go and use Stripe or PayPal to charge the credit card. There's also scenarios where you want to do stuff like randomly generate a number, get the current time, these types of like non-item potent types of operations. Oh, another really good one is I'm going to get bcrypt I'm going to save a user's password in the database. And so the normal way to do that is to call bcrypt. There's built-in functions in Postgres SQL to be able to do that. There's obviously libraries to do that. When you go to password, to salt and generate a bcrypt hash of your password, it's random, right? Because it's randomly generating the salt that it's going to use. And so if you're going to execute a workflow, so go back to the scenario we were talking about before. I'm going to have a series of steps, and I need to make sure that I'm resilient to it crashing in the middle, right? So I execute, I update the database, I call out to Stripe, and I'm waiting for a response back, and, the hardware crashes. And once you get it back up again, you need to be able to say, okay, this workflow was in process when we crashed, so let's start it again. Step one, reserve inventory. We already did that. Don't do it again. Step two, talk to Stripe. Well, we already did that. We're waiting on a response. Now, of course, in that kind of specific scenario, I'm talking to Stripe, maybe, you'd have to have some mechanism to be able to go and talk to Stripe, right? It doesn't, recovery isn't necessarily magic, but these external communicators are for these types of operations. So if you were to imagine, like, I'm going to so I'm creating a new user in the database. And so the user gave me a name and password, and I'm going to bcrypt hash it. If I've crashed between hashing and saving it in the database, I don't want to regenerate that hash. I want to use the same hash that I did before. So in that kind of a scenario, when I go through and say I'm rebooting the workflow and starting it over again, I go off and I say, okay, here's these external functions. It's already executed. I've saved this. I've restored the state. So again, each of these individual steps, we save the output of your function call. So that way, if we need to re-execute it, we don't execute operations a second time. Mm-hmm. And this turns out to be really important in a lot of event handling systems. We recently posted some articles. We have Kafka integration. And so Kafka integration, it's very easy to get at least once event handling, but most transactional systems don't want at least once, they want exactly once. And the way you achieve exactly once is by having an item potency key of some sort and at least once. You can execute it multiple times, but if you execute it multiple times, you're safe. So external communicators, and then internal, I'm talking to my database, I'm doing that inside of a transaction. So that's basically just, any kind of stuff that you're going to do to talk to the database.
Okay.
The most recent thing, which I was primarily focused on, is adding a new type of transaction function called a stored procedure. Now, of course, I'm sure you've heard of stored procedures. Go figure.
I love store procedures.
All right, everybody drink now.
Yeah, we have a drinking game.
Then this is, boy, howdy, I'm on the right podcast, man, because I think you're in the minority, Chris, right?
Probably am.
Most people don't like using store procedures, right? You typically have to write them in a different language. They don't integrate well into your developer workflow. They don't version the same way that the rest of your code does. You can't debug them the same way the rest of your code does. And so store procedures and DBOS, we basically solve those problems. So the reason the store procedures are so powerful is because you're co-locating your business logic, your logic in the database. And so like even any kind of normal transactional system, you've got at least 3 round trips to the database. You're going to begin the transaction, you're going to do 1 query, and then you're going to end the transaction. It turns out in DBOS, there's more round trips to the database because of the reliability guarantees. We have to save the results of your transaction function in the database in the scope of the same transaction that we started. So it's start transaction, run your code, save the result, end transaction. And it turns out there's a couple of other scenarios. If it's a recovery, like, oh, we know that this is a recovery, so we have to check to see whether or not this transaction has been executed before. That's another round trip to the database. Because read-only transactions are much faster than read-write, we don't save read-only transactions at the time that you execute it. We save them before you get to a write transaction. So now you're looking at begin transaction, check to see if the operation's been completed, save any cached read results, do the thing the user wanted, save the result, and commit the transaction. So you're talking about 6 round trips to the database. With a stored procedure, you can do all of that in 1 round trip, which makes the performance dramatically better, like an order of magnitude better or something. I don't remember the specific numbers because even though I wrote the code for this, I didn't actually do the benchmarking. We recently published a benchmarking one. I think it doubles the speed, like for the simplest hello world scenario. But then how do you go back to the problems we were talking about? Well, so first off, there's a great plugin for Postgres called PL V8. It is a Postgres language, PL, that uses V8, the JavaScript runtime from Google that powers Chrome and Node and etc. So you can actually write your stored procedures in JavaScript. And of course, if you write them in TypeScript, you can use the TypeScript compiler to convert them to JavaScript. So my big feature for the last epic that just ended, I don't know if I mentioned, I was in Boston last week for our all hands planning meeting. This project was founded out of MIT because that's where Stonebreaker teaches. Was to build a compiler that automatically extracts the functions that you've labeled as stored procedures and all of the code that they depend on, right? So, not just the code of the stored procedure, but any code in your project that it depends on, and deploys it all to this database and all of that additional DBOS logic that guarantees once and only once execution. So now you can do all of that work in 1 round trip. We version those queries the same way that your code does. So when you deploy to DBOS Cloud, and you can do this locally as well, but with DBOS Cloud, every time you deploy, we give it a version stamp, right? The current Unix timestamp. So when we deploy your stored procedures, when we run the DBOS compiler, we automatically prepend a V and then the timestamp on all of your methods. So that way you can automatically publish. Every time you publish a new version of your code, you publish new versions of your stored procedures that do not conflict with the old versions of your stored procedures. And then we clean up the old versions once we're sure that all of the old versions, when we have these kind of outstanding, we're still in the process of handling workflows. We make sure that we know what version each workflow, what version of the code goes with each outstanding workflow. So we don't clean up old code until such time that all the old workflows for that version of the code have executed to completion. So we don't clean up your stored procedures until that point in time either. But so that way you get the same versioning experience. We don't debug inside of the database, but during the debug experience, we run the code locally. Now, for time travel debugging, we always throw away your result and only use the saved version, right? So, like, for example, you can change your code for time travel debugging for like getting queries, but you obviously, this isn't, I'm not Marty McFly. We're not going back in time and changing the past, right? So you can find out what it looked like at the time, but you can't change like inserts and stuff like that. But you can, but you can read that state. So we do those so we execute that code locally. And we'll do the same thing. You can actually flip a bit in a store procedure function to say, hey, I want to run this locally so I can test it in the debugger. There are some slight differences between using the Node Postgres like database driver. It's a package for talking to Postgres that we use versus using PLV8. One of the things we found, for example, is the way that it handles floating points. Go figure. Always floating points are always a problem. The exact value where it rounds, those things are a little bit different. But generally speaking, the vast majority of your code is going to run the same, whether you're running it locally or whether you're running it in the database. So you can debug it locally and still execute it in the cloud, execute it in the database for maximum performance.
Mm-hmm. Cool. Well, you mentioned, right, like I had this question just reading through the documentation. You kind of hinted at it, but it's like, I was wondering when I was reading through the DBOS documentations, like, why did you folks decide to settle in on TypeScript and Node.js?
I asked this question when I interviewed.
Yeah. Okay, good. So you got the right answer. I guess
I came from .NET, right?
Yeah, we do too here. Yeah.
It's funny. I worked with Pat Helland for a while when I was on the architecture strategy team I was mentioning earlier, and Pat and Mike Stonebreaker wrote a paper together. Pat is also an industry luminary in the database space. So I picked his brain as part of the interview process. And one of the questions I asked in the interview is, why don't you guys use C#? It has a built-in query infrastructure. It would seem like a really good fit. And of course, these are academics, right? This project came out of academia, and C# is not very popular in academia relative to Java. And it was a very succinct answer. None of our customers are asking for it. Mm-hmm. So we started with TypeScript because of its popularity, right? Obviously, TypeScript is an extremely popular language, and we are, in fact, growing that out. We've announced a Python version. We have ideas about other languages too, but obviously nothing to talk about it yet. It's popular, and it turns out to be really interesting for this kind of stuff. It's some of the things that you can do with the TypeScript type system are really fascinating. So one of the things that we found, for example, is we don't want customers to call methods directly, right? That's one of the things that's kind of weird about these types of systems relative to sort of traditional development, right? Because I want to intercept every single call that you make to a workflow, because I need to start the workflow. I need to save data in the database. When a workflow calls into a transaction or into a communicator or a store procedure, there's stuff I have to do, right? I'm calling that store procedure function, but under the hood, I'm actually going to make that into a call to, store procedure name under the hood. So we have to intercept each one of those calls. And in fact, C# in particular used to be much more capable in that space, but those features have gone by the wayside, like Marshall by ref interception type stuff. Like .NET doesn't really support that kind of stuff anymore. But in TypeScript, it's actually relatively easy to do things like say, first off, because JavaScript's a dynamic language, it's really easy to say, I'm going to build this object on the fly. And so I'm going to create an object that has the exact same signature except for the first parameter. So the first parameter is the context object. So, for example, in a transaction or a store procedure object, that's where you get your connection to the database. In a communicator, that's where you get information about retries. Oh, this is the second time we've retried it, what have you. In a workflow, you get information about how to communicate inside and out of it. You can raise events. You can send and receive messages. You can get information about the item potency key, the way that we guarantee once and only once execution is in part via having a unique identifier for every individual workflow. But you don't want to expose that to the developer, right? That's something that we create. So when you call, if a workflow is going to call into a transaction, there's a special function you call in the context called invoke. So you say context.invoke, and you pass it as a generic parameter, the name of the class. These are all static methods on classes. And then you pass it the parameters. We then translate that, create the context, and do all that work. Doing the dynamic part of that at runtime, that's easy in JavaScript. But having the type-safe way of defining that, that's a lot harder. But TypeScript makes it easy, right? TypeScript has this whole construct of utility types where you can define types in terms of other types. And it's a Turing complete language. Some guy built Flappy Bird in the TypeScript type system, which I don't have the patience for that, but that's weird. But it's cool. And you can do some really radically awesome things with the TypeScript type system. So picking TypeScript, it turned out to be a really great choice for us to start with.
Cool. So I take it that Python, now that you're supporting Python or working towards supporting Python, so Python will get compiled and get moved into stored procedures also?
Yeah, I'm not 100% sure about how we're going to do the Python stored procedures.
Okay.
So I think we're going to have to hold off on having that conversation.
That's cool.
Yeah, there is a Python language implementation for Postgres. In fact, it comes out of the box. PLv8 is a third party, but it's very popular. It's supported in AWS and Azure and all the major cloud vendors. There is a Python one, but it's untrusted, so it's not clear if we can do things the same way.
Yeah,
so
gotcha.
I have ideas, but that we're starting to get into the areas of stuff I'm not really quite ready to talk about.
Yeah,
Awesome.
I mean, my brain immediately goes to, I swear I saw WebAssembly support inside Postgres. That could.
There's WebAssembly. There's .NET.
Yeah.
There's Rust. There's some. It's amazing. Postgres is really the Swiss Army knife of data storage these days. It's got some really great, powerful features.
Yeah. So. Well, let me ask you a follow-up question, right? Like you mentioned TypeScript, and obviously TypeScript is a superset of JavaScript.
Yep.
Being a dynamic language, Python dynamic language, very similar to kind of what you could do at runtime with JavaScript. Is there something limiting your implementation from, say, adopting a statically typed language like C#?
No, not at all. The original research project was called Apiary, and it was all Java.
Oh, okay.
Now, it was written on top of BoltDB, which is, as it turns out, another Michael Stonebreaker startup. And BoltDB supports stored procedures written in Java. So part of the research there was about, how much better performant it is if you move your logic to live inside of the database. And so a lot of these projects are about how to make that feasible, and again, integrate it into the developer workflow. But no, there's no reason that we couldn't do this for Java or C# or any of the other languages that are out there, other than just engineering time and effort.
Yeah.
You can imagine, given the popularity of Python, right? I mean,
yeah, very popular. So, so we've talked about all this foundational stuff. How can, and I know we're kind of coming up to time, and I want to have enough time to talk about how a developer gets into, like, where are the tools? What do they have to have? What do they have to bring to the table to start working with DBOS?
So they need to have an application that uses the database, right? One of the things we talk about a lot is how much we haven't had a chance to really talk about this. We haven't had a chance to talk about the cloud very much, the DBOS Cloud very much in this conversation, because we've been focused on developer experience, and that's what I like to talk about. We could talk about this for hours. But the cloud, the DBOS Cloud, it's an order of magnitude cheaper and faster than, say, AWS for these types of database style workflows. We've got case studies on our website, like 15 times cheaper than AWS Lambda, 25 times faster than step functions. One of our early adopters actually had this really great quote: "We got farther in 2 days on DBOS than we did in 2 months on AWS." So it's faster, it's cheaper, and it's more productive than doing these types of systems on the cloud. But it's very specifically for these kind of data-oriented systems. If you're, processing video or something like that. That's not, these kind of transactional databases is the sweet spot for these types of systems. The actual framework is open source. And so we have, of course, in the documentation, instructions for how you can create a new project, how you can, write transactions, store procedures, workflows, communicators, etc. All these other, and there's a lot more advanced features, as I mentioned, kind of like raising events and sending messages between workflows or from workflows to outside of the DBOS world and that kind of stuff. And then we also then have a hosting service for these applications. It's really easy. In fact, we just published yesterday, a new web console so that you can actually, deploy these types of applications. You can see all of the state of your cloud resources, and as you can imagine, we are expanding that out so you have a really great developer experience that goes from the cloud to your computer. And we do have a pretty generous free tier, so developers can get started for free. Just sign up on dbos.dev, and the professional tier is $40. So it's pretty inexpensive, even if you're going to go into a paid style service.
Cool. And then what developer tools, what IDEs, what like?
Clete, you have to put your hands over your ears.
Oh no!
We have a Visual Studio Code extension for the time travel debugging. So you can like click directly with a code lens right in your code. It will ask you to pick a workflow that you want to execute. There's an entire observability backend that we haven't really even had a chance to talk about because it's not really my expertise. But you can actually, like, from the console in the cloud that shows you every execution of every workflow in your entire system, there's a link that you can say, I want to debug this one. And it will automatically launch. Well, Visual Studio has to be launched, but there's a URI handler in Visual Studio Code. So that way it'll launch the debugger, the TypeScript debugger for that specific workflow, executing at that specific point in time. And again, it uses the time travel debugger, as we talked about earlier, to be able to then see exactly, to get exactly what the data was at the time of that workflow's execution. So we have this really nice communication from the developer tool on your machine, running out, connecting to the cloud, and then coming back. We do want to provide, I will say, I mentioned earlier that I'm not a very good UI developer, and the extension is one of the pieces of the product that I own. I'm very excited that we have a front-end developer now who's going to help me actually build some better UI in the extension for these kinds of features. Because right now it could be better, right? The ability to pick, which workflow you want to execute. You kind of have to use the cloud to get a good experience there.
Well, there is another company that maybe you can build some extensions for
I would be happy to. I just don't know very much about it. If only somebody could give me some guidance in that space.
All right, we'll talk after the podcast. But if anybody out there is listening, they want to write extensions for JetBrains products, we have a Slack channel. You can always join.
We're cool. Yeah, no, I'll definitely take a look at it. Right, we are a small company, so there's only I think at this point we have 9 engineers, but that includes a very fantastic college intern, and so we don't have a ton of bandwidth when it comes to new stuff, but we will definitely take a look at that. I'm well aware of the fact that JetBrains is a very popular developer platform. My last job also involved building Visual Studio extensions, and then there was a guy from the community who was replicating some of those in JetBrains, and it was really they were doing some pretty cool stuff.
Yeah.
Cool. Awesome. Well, we're going to start winding down, but Harry, is there any kind of we'll give you 30 seconds to do one last pitch to something maybe we didn't cover that you'd like to at least throw out there for people to know about?
So, I mean, there's so much more that we could have talked about, right? We could have talked about the ability to leverage this same provenance database to do point-in-time recovery in case of like a ransomware attack. There's the built-in observability of the platform that is Like you observability is one of those things you have to get right from the beginning, right? And so as a developer, the whole point here is we want to take the drudgery out of this, right? Woody, you and I have been in this industry. Khalid, you and I have only just met, so I'm not trying to exclude you, but we've been through this cycle where things get more and more complicated, and then people are like, "This is too complicated. We need to simplify." And it feels to me like we're at that kind of a point now, right? You talk to customers about like the amount of infrastructure they have to do to manage these kind of like workflow systems, the Kubernetes team and all this other stuff. And it's so complicated. And so working for a company that has this audacious goal and also this very, very strong ethos around radical simplification of the developer experience, it's a really compelling story. And I'm really excited to get a chance to talk to you guys about it today.
Cool. Well, we will insert all, like, you send us some links. We probably won't get this episode out for a few days. So if there's anything you want in the show notes, we'll put it in there. We'll put some videos but now this is fascinating. And well, one, it's good to catch up with you, Harry.
It's great to see you, man.
Yeah. We have to kind of see each other in 3D. I'm getting tired of seeing everyone in 2D. But like
the next time you're going to be in Redmond,
I don't know. I'll try to figure it out. But yeah. So Khalid, do you have any parting gifts for
it was great. It was great to actually talk to Harry. This stuff's really fascinating, especially kind of the idea of workflows, transactions, time travel debugging. So I really recommend people just go out, watch some videos, try it out. Yeah. You can do everything locally. So you can sign up.
We all work for the most part, we all work in business and everything is just workflows. Like I am working on like a new inventory system, and we have inventory, like receiving inventory and transferring inventory and returning inventory and turning demo devices, like it's all around cell phones.
And we guys, you're storing all that information in a database.
It's all
we are.
Brain.
No, it's not in my brain. If it was, we'd be out of business. But
and one of the things that makes DBOS so performant is, hey, if you're going to have a database to store that information, maybe you could also store your workflow data in that same database. So many of the external systems that do this, it's like, oh, I have to manage this separate system over here and this system's over there, and this is all in one, which it makes it faster and cheaper and simpler and more productive.
Yeah. Cool.
All right.
Okay. With that, we are going to let Harry get back to writing code. So
the world's ugliest switch statement. That's what I'm working on.
And playing with the dog and doing all that. But Harry, we really appreciate you joining us.
I appreciate you guys giving me a chance to come on and talk about this stuff, man. I appreciate that a ton.
And tell your lovely wife the next time I come out, I will bring Red Pop Fago. Yep. So
we actually there's a place where we can get it locally now. As it turns out.
Good.
Ooh,
that's good.
He doesn't need you anymore, Chris. That's why.
Don't say that.
No, then I don't have to worry about exploding 2-liter containers in my luggage and stuff.
Yeah, TSA might have a problem with that.
Yeah. So, well, thank you again. Fascinating, and maybe we'll bring you on in the near future to talk about something else, maybe some other developer experience stuff. But and Khalid, it was a pleasure to share this time with you. And Martin, we missed you, but we had a great time.
I'll have to do this again just so I can hang out with Martin.
Yeah,
absolutely.
Yeah. Martin's a great guy. Martin the Machine. Yeah. So cool. Well, everyone, have a great rest of your day, and we'll see you in 2 weeks with the next episode. And sayonara.
Bye, everybody. Bye.